Hi, for this short visual lecture, I'm going to talk about CU or control unit. So this is adapted from www.geeks4geeks.org. So what is a control unit? Control unit is the part of the computer's central processing unit or CPU which directs the operation of the processor. It was included as part of the von Neumann architecture by, of course, John von Neumann. It is the responsibility of the control unit to tell the computer's memory, arithmetic logic unit, and input and output devices how to respond to the instructions that have been sent to the processor. It fetches internal instructions of the programs from the main memory to the processor's instruction register or IP. And based on this register contents, the control unit generates a control signal that supervises the execution of this instruction. So if you remember our von Neumann machine, this is the control unit or the CU. A control unit works by receiving input information to which it converts into control signals, which are then sent to the central processor. The computer's processor then tells the attached hardware what operation to perform. The functions that a control unit performs are dependent on the type of CPU because the architecture of CPU varies from manufacturer to manufacturer. Examples of devices that require a CPU are central processing units, of course, there's CPU, and graphics processing units or GPUs. So here are some of the functions of the control unit. So it coordinates the sequence of data movements into, out of, and between a processor's many subunits. It interprets instructions. It controls data flow inside the processor. It receives external instructions or commands to which it converts to sequence of control signals. It controls many execution units like ALU, data buffers, and registers contained within a CPU. And last but not the least, it also handles multiple tasks such as fetching, decoding, execution, handling, and storing results. So in your CPU, if your ALU is the brain of your CPU, the CU is can be uh, can be likened to a control or a traffic controller. So you have a traffic controller and you have the brain of your CPU. So types of control unit. So there are actually two types. You have the hardwired control unit. In the hardwired control unit, the control signals that are important for instruction execution control are generated by specially designed hardware logical circuits, in which we cannot modify the signal generation method without physically changing the circuit structure. The operation code of an instruction contains the basic data of control signal generation. In the instruction decoder, the operation code is decoded. The instruction decoder constitutes a set of many decoders that decode different fields of the instruction opcode. The second is microprogrammable control unit. The fundamental difference between these unit structures and the structure of the hardwired control unit is the existence of the control store that is used for storing words containing encoded control signals mandatory for instruction execution. So in microprogram control units, subsequent instruction words are fetched into the instruction register in a normal way. However, the operation code of each instruction is not directly decoded to enable immediate control signals generation, but it comprises the initial address of a microprogram contained in the control store. So with that, I thank you for listening. I hope you will also read more about the CU or the control unit. Most often than not, we just take CU for granted, but we really don't know that it's the one doing all this, not really the heavy lifting, but all the uh, allocation of resources, where to get these things within the CPU, which data should go in first, the ALU, and all this stuff. So again, thank you for listening.